section 1 of Unit 4. In this unit, we are going to look at back titration. There are certain quantities of substances that you cannot determine by direct titration or by directly titrating them. And so, in such cases, you may have to consider this method, that is the back titration. This session is on back titration, and we are specifically going to look at how you can determine the calcium carbonate content of a limestone. Let's move on to look at our objective. By the end of this session, you should be able to determine the calcium carbonate content in a limestone using the back titration principle. Let's proceed. The back titration is a method to determine or used to determine quantities of substances which cannot be determined directly by titration. Let's take this example, and by the time we finish solving, we would understand back titration very well. But before we go there, listen to this scenario. Let's assume that you are three in your house: yourself, your sister, and then your father. You are hungry. Your sister is also hungry. And then your father gives you 10 balls of kinky. You have the freedom to eat some. Your dad will not do anything to you. Just eat some and then give the rest to your sister. So you eat some and then you give the rest to your sister. If you don't tell us how many balls of kinky you ate, how do we get to know? Yes, we will know the balls of kinky you ate by starting from your sister's end. So we'll first go to your sister and ask her, how many balls of kinky did you give her? If she tells us the number of balls of kinky you gave her, then we can go back to the total balls of kinky that your dad gave you and find the difference. So if we subtract what you gave to your sister from the total, then we'll know the quantity that you ate. So the excess is what you are going to give your sister. When you ate, the leftover is what you are going to give to your sister. Now back to this example. The calcium triisocarbonate 4CaCO3 content of a limestone can be determined by reacting a weighed sample of the limestone with a known excess of HCl, and then there is a follow-up equation. Let's now come to the task. A is 0.10 molar sodium hydroxide. Let's look at how B was prepared. B is the solution obtained by dissolving 4.03 grams of powdered sample of limestone in 1 dm cube of 0.15 molar HCl and filtering off any residue. Before we proceed, for the sake of comprehension, understanding, let's analyze the solution B very well. As a titration, we expect acid-base reaction. We are titrating between acid and a base. The A, we are sure it is base. But look at the B. We have two species there. We have the acid and then the calcium carbonate. Here there is going to be a reaction. The calcium carbonate is first going to consume some of the acid. So the leftover of the acid is what is going to react with the base. The excess of the acid is what is going to react with the base. So for whatever the follow-up questions are, we first have to approach the question from the base, the NaOH, find the moles, and then find the mole ratio and get the corresponding moles, convert it into concentration. That concentration is going to be the excess after the calcium carbonate has taken some away. Now let's proceed. So put A as an instruction. The questions that follow are: from the results and information given, calculate the number of moles of HCl per dm cube, that's the amount concentration, and then the number of moles consumed when the limestone was added, the mass of calcium carbonate present, the percentage by mass in the sample of the limestone. Let's look at how to solve this problem. As usual, we will take it from the side that we have enough data, and that is the base, the sodium hydroxide, because we have the concentration, we have the volume, and we can find the molar mass. But taking it from the concentration of the sodium hydroxide, in the question there was a concentration of 0.1 mole per dm cubed. We need to interpret that 1000 centimeters cubed contains 0.1 mole. Then out of that 1000, we have the average volume of 20 cubic centimeters. 20 cubic centimeters was fetched out for the process. So if that 1000 contains 0.1, then that 20 that was taken out will contain, we do this and we get 0.002. So this is the number of moles in the 20 cubic centimeters that reacted with the small volume of the acid as well. So we come to an equation of reaction between those two species, the acid and the base. And from the equation, the mole ratio is 1:1. If the mole ratio is 1:1, it means the number of moles of the base will be the same as the number of moles of the acid, which is 0.002 moles. Remember, this 0.002 moles is the moles of the acid that was in just 25 cubic centimeters of the acid that was used, not the thousands or not the large volume there. So we have to convert this moles in 25 into moles in 1000 cubic centimeters. So if 25 contains 0.002, then 1000 will contain what? And by this we have 1000 times 0.002 over 25.0. And that gives us 0.008 mole per decimeters cube. And that is our amount concentration. We are done with that part. But can we draw any meaning from this? What we have here is the excess concentration. After the carbonate has taken some away, what was left is what came to react. So this is the excess. Now, the next is to find the concentration of HCl that was consumed. Then from there, we can now convert it to moles. We started with 0.15 molar HCl or mole per dm cube HCl, and we have found that out of that there was excess. The calcium carbonate took some, and what was left was the 0.008 as we have found. So if we want to know what the calcium carbonate consumed, it's just a matter of subtracting the excess from what we started with, which is the 0.15. So when we find that difference, we have 0.007 mole per dm cubed. So this is the concentration of the HCl that the calcium carbonate consumed. In other words, this is the number of balls of kinky that you consumed. Now that we know this concentration, we can now convert it into moles. And with this, it's simple. We are using the relation concentration is equal to amount in moles over volume. So we do a change of subject such that the number of moles stands alone. And here we have our concentration, which is 0.007. And in the question, the volume was there as 1 cubic decimeters. We do a substitution and we have this answer, that is 0.07 moles. So it is this mole of the HCl that was consumed. Okay. The next one is to find the mass of the calcium carbonate. In finding the mass of the calcium carbonate, we need to do something. We have to look at, so we now know the moles of the HCl that was consumed. We have to write an equation to show the reaction. Then we use the mole ratio to find the corresponding moles of the calcium carbonate. Okay, so this is an equation, and from this equation, for every 1 mole of calcium carbonate, we will have 2 moles of HCl reacting with it. It means that the moles of HCl is equal to, or moles of the calcium carbonate is equal to 2 moles of HCl. If that is the case, then moles of calcium carbonate will be 1/2 times the moles of the HCl that was consumed. In other words, if 1 is equal to 2, then X is equal to 0.07. When we do that, we get 0.035 moles of the calcium carbonate. So if we have this, the question was to find the mass. And we know that we can find mass from the amount and molar mass. So we find molar mass, and the molar mass of calcium carbonate from the atomic mass is 100. From the atomic masses is 100 grams per mole, and the moles to use is what we have found to be 0.035. So when we do this substitution, we have 3.5 grams. So that's the mass of the calcium carbonate. The next is to find the percentage by mass of the calcium carbonate, and it is simple. We know the total mass that was used to be 4.03, out of which 3.5 is calcium carbonate. So to find the percentage by mass, we just have to divide the mass of the calcium carbonate that we have found by the total mass times 100, and that gives us 86.8%. In other words, for the whole of the mass that was weighed, 86.8% of it was calcium carbonate. Okay, so that brings us to the end of this session. I hope you enjoyed it. Let's meet in the next session.